Hey guys, this week you all are learning about the Pythagorean theorem. So I just wanted to go over some problems with you guys. So let me share my screen with you. All right, we'll look at these problems together. So first of all, since you've been reading and learning and looking at the videos, you know that Pythagorean theorem is all about right triangles. So when you're looking at a right triangle, all right triangles have two legs. Those two legs form that 90-degree angle. And then across from that 90-degree angle is the longest side, which is called the hypotenuse. And in the Pythagorean theorem, C is always the side of that's considered the hypotenuse. A and B can be interchangeable, but C must be the longest side. So the Pythagorean theorem says if we square the two legs of a right triangle and add those two legs squared together, we're going to get the hypotenuse squared. So the two legs in this situation is 6 and 9. So 6 squared plus 9 squared is going to equal C squared. Well, 6 squared is 36. 9 squared is 81. So where's my calculator? So 36 plus 81 is 117. So the hypotenuse is not 117. The hypotenuse squared is. So how do we undo a square? How do we undo multiplication? By division. How do we undo addition? By subtraction. So how do we undo squaring a number? We find the square root. So in our calculators, we find the square root of 117. Hit that double arrow button so I get a radical like that. So I want to turn that into a decimal. So above the enter button, I see a double arrow button right here. So I hit that, and now I'm going to round my answer to the nearest hundredths. So the hypotenuse is about 10.82 units long, which makes sense because the hypotenuse always has to be the longest side, and 10 is longer than 9 and 6. All right, number 2, 13 and 4 make the legs of the right triangle. The hypotenuse is our missing side because it's across from that right triangle, or the right angle, I should say. So we're going to do 13 squared plus 4 squared. Doesn't matter which is A and which is B, but the hypotenuse must be C squared. So 13 squared is 169, plus 4 squared is 16, equals C squared. I think 13 squared is 169. Yes, it is. Plus 16 is equal to 185. So 185 is equal to the hypotenuse squared. So to find the length, I'm going to find the square root of 185. I just plug it right in my calculator. And my answer is about 13.6. 13.6 is our hypotenuse, which is the longest side, which makes sense. Now this time we're given the hypotenuse. So we're missing either A or B. So we're going to start with the theorem. All right, 3 could either be A or B. It doesn't matter. 6 has to be the hypotenuse, which has to be C. So 3 squared is 9. C squared, oh, whoops, I meant to put 6. 6 squared is 36. I'll go ahead and put 36. All right, so now we want B squared by itself. So we're going to subtract 9 from both sides. So B squared is equal to 36 minus 9 is 27. So the leg B is going to be the square root of 27. And the square root of 27 is about 5.2, which is shorter than our hypotenuse. 5.2 is smaller than 6, so that makes sense. All right, number 4. Our A is going to be 10 or B. and our hypotenuse is 11. So 10 squared is 100. 11 squared is 121. We want b by itself, so we subtract 100 from both sides. So b squared is equal to 21. So b is going to equal the square root of 21, which is about 4.6. 4.6. All right, so that's how you find the hypotenuse or a missing leg. All right, and you could do the same thing with this, just you're gonna square 6, subtract it from 8 squared, find the square root of that answer, and it's gonna be letter B. So there's some more practice for you. If you wanna pause, write these down. I'll be happy to send you the answers if you wanna try those. Practice always helps. All right, look at these aren't numbers. So the question is, what is the perimeter of these triangles? Well, the only way to figure out the perimeter is to figure out the missing side lengths. So on the top one, we're missing the hypotenuse, and the bottom one, we're missing a side length. So we would use the Pythagorean theorem to figure out our missing side length, and then in order to find the perimeter, we would just add those numbers together. So 144 plus 36 is 180. So the square root of 180 is about what? About 13.4. And then we would add 12 plus 6 plus 13.4. 9, 10, 11, so 31, about 31.4 is the perimeter. All right, and the bottom one's similar, except this time our leg is missing, so this is a subtraction problem on the bottom. When the hypotenuse is missing, it's an addition problem. When the hypotenuse is missing, it's a subtraction problem. All right, what about these? These are rectangles, right? So what if you have a question like this? What are the lengths of the diagonals of the rectangles? And you have some of those on your practice problems for, I think it's Friday, real world problems. So basically the horizontal or the diagonal is the hypotenuse of this right triangle or this right triangle, okay? And like I said, you'll have some of these to do on Friday. So basically, A and B are 16 and 63. And the diagonal is the hypotenuse. So you would do it just like the other problems. All righty. Sometimes you'll be asked to prove whether or not a triangle is if a triangle is a right triangle. Is the following triangle a right triangle? To see, you're going to use the Pythagorean theorem. So this says, obviously, the triangle is not drawn to scale. So if we want to prove whether this is a right triangle, we're going to take the two shorter sides. We're going to square them. So 2 squared plus 4 squared. So 2 squared is 4. 4 squared is 16. And 5 squared, which is the longest side, is 25. So now does 16 plus 4 equal 25? No, it equals 20. So that means that this triangle could not be a right triangle, not because of the way it looks. Obviously, it doesn't look like a right triangle, but because of the side lengths will not form a right triangle. All right, so what about these? First of all, you find the hypotenuse, which is the longest side. So 13 is the longest side, so we're going to say, okay, does 12 squared plus 5 squared equal 13 squared? Well, 12 squared is 144, 5 squared is 25, and 13 squared is 169. So is this true? What's 144 plus 25? It is 169. So since this equation is correct, then that means that this is a right triangle. All right, number 5, find the longest side, which is 14. So we're going to let 14 be C. So 9 squared is 81 plus 144. And 14 squared, I do not know, is 196. And then I want to see, does 144 plus 81 equal 196? No, it equals 225. Since 225 does not equal 196, the answer is no. This is not a right triangle because the Pythagorean theorem tells us it's not. All right, now the other type of problem you're going to have this week is three-dimensional figures. So that diagonal across the three-dimensional box would be the hypotenuse of the triangle formed by this triangle inside the box. So instead of having two dimensions to add together, to square, add together, and find the square root of, we're going to have three dimensions. So since boxes have a length, width, and a height, you're actually going to square 5, you're going to square 6, and you're going to square 8. So 5 squared plus 8 squared plus 6 squared is going to equal that three-dimensional distance from the top corner to the bottom corner. So 5 squared is 25 plus 64 plus 36 is equal to D. Actually, we're going to D squared, actually, yeah, because these are all squared. So then 25 plus, well, I know that 36 plus 64 is 100, and 100 plus 25 is 125. So that three-dimensional dimension is going to be the square root of 125, which is already answered for us here on the bottom of the page. So it's 11.2 centimeters. All right, so if you have another box and the dimensions are 2, so we have 2, 9, and 7. 7, 9, and 2. Well, that three-dimensional length is going to be 7 squared plus 2 squared plus 9 squared is going to equal that distance squared. So we have 49 plus 4 plus 81. So my calculator, 49 plus 4 plus 81 equals 134. So the distance is the square root of 134. 134 is 11.6, about 11.6. So that's how you guys are going to do those. All right, one other type of problem I've solved for this week is finding the shortest distance between 2 points. So you are given 2 points on a coordinate plane, and they have it's a diagonal like this one. So basically what you're going to do is you're going to use those 2 points. You're going to think, okay, this can be the hypotenuse of a right triangle, and now I'm going to create, I don't know why I can't draw straight lines, you guys. I'm going to draw a right triangle, and now I can use the Pythagorean theorem to help me find the distance between these 2 points. So the height of this triangle is 1, 2, 3, 4, 5 units tall. 1, 2, 3, 4, 5, 6, 7, 8 units wide. And I do not know that diagonal, or in other words, the hypotenuse. So 5 squared is 25, 8 squared is 64, and that length is 25 plus 64 is 89, and I'm going to find the square root of both sides. So the square root of 89 is about 9.4. So that line is about 9.4 units. All right, let's look at another one. So suppose you're given the 2 points, -1 and 2. So let me graph this, -1 and 2 right here. And 2, -4. So 2, -1, 2, 3, 4. And they want to know how far apart are these 2 dots right there. Wow, that's probably the best line I've ever drawn. So we're going to make a right triangle either above or below that line. It doesn't matter. I'm going to count my units. So this is 1, 2, 3 units wide, 1, 2, 3, 4, 5, 6 units tall. So we know that 6 squared plus 3 squared is going to equal that distance squared. So we have 36 plus 9 is equal to 45. And the square root of 45 is about 6.7 units. So we could guess, right? But we can't know exactly. It's a diagonal. It's not, it's not easy to count like this straight line here from this corner to this corner is exactly 3 units long. All right, maybe one more. What else we got? How about this one? Let's do this one. All right, so we're given 2 points. So we have 4, 3. So we're going to go from the origin right 4 up 3. And then -3, 1, 2, 3, +4. Right there. Oops, I got it wrong. It's -3, +4. And then, oh my goodness. All right, so we're gonna make our right triangle. We're gonna pretend like everything's perfect. The unit is 1 by 1, 2, 3, 4, 5, 6, 7. So 1 squared plus 7 squared is equal to c squared. So 1 squared is 1 plus 49. So the answer is the square root of 50. So c is equal to the square root of 50, which is 5 square roots of 2, which is about 7.1 or 7.07 units long. All right, guys, so that's how you're doing that. And I saw all types of those. All of those are types of questions that you'll see this week, okay? All right, so hopefully that helped a little bit. And if you need me or have any questions, please let me know and I will help you out. Y'all have a great week.